Hello, Algebra 1 CP students. Hopefully, you're having a great day so far. Today, I would like to talk to you about applications of linear function word problems. What I mean by that are problems that relate directly to our slope-intercept form, our y equals mx plus b, one equation and one variable. I know that I initially told you that we'd be doing systems of equations word problems today, but I think it's definitely worth it to take one more day to do a real deep dive on linear function applications. Don't worry, the word problems on systems of equations are coming soon. I also realized that there's one of these types of problems that we didn't really take a look at yet, and I think is really important for you to see. So we're going to take a look at that today. Again, you probably noticed we're doing a bit of a deep dive, really breaking down what each part of the formula and y equals mx plus b, what each term of that represents, and hopefully being able to solve some, again, real world applications. So let's get started without any further ado. This first problem should seem very familiar to you. We've done a lot of these types of problems by now. It states an attorney charges a fixed fee of $250 for an initial meeting and an additional $150 for each hour worked. What it's asking us now is to write an equation in slope-intercept form that models this scenario. So slope-intercept form, remember, is our good old friend y equals mx plus b, in which m is the slope and b is the y-intercept. X is the input of the function, y is the output of the function. So which one of these pieces of information in my word problem ties into the y-intercept, ties into just a constant? And likewise, which one ties into the slope? Well, in the word problem, we're given this constant expense, this fixed fee. $250 is what this attorney charges, regardless of whether she works for 1 minute or 1 day. So that, in this case, is our y-intercept. It's just our constant. Notice, no variable attached to it. It's not changing over time. It's not a rate of change. It's just flat $250. So we're going to start by saying y equals. I'll leave my slope empty for now, but I will put my plus 250 here. Okay. Now this, if you notice, is a variable change. It's a rate of change in the sense that the attorney charges $150 for each hour worked. How many hours were spent working? Well, we don't know. So we could represent that information as x and say that how much we have to pay would be 150 times x. Again, plus the 250 initial fixed fee. So that is our equation in slope-intercept form. Each part of that equation, again, represents something that ties into the scenario. The slope represents the rate per hour, right? Because every hour worked, which is represented by x, that means that I have to pay an additional $150. What does the y-intercept represent? Well, that represents the fixed fee, the one-time initial fee that never gets assessed again, but again, regardless of that rate, you got to pay it. That's $250. Now, the next problem says, how much will the attorney charge if she works for 8 hours? Well, if she works for 8 hours, that gives us a direct value for x, saying, oh, well, if x is 8, then how much do I have to pay? We can figure that out by just plugging in 8 for x. Hopefully you understand how these relate to this, by the way. But anyway, plug in 8 for x, we would say, well, how much do I have to pay? Y equals 150 times 8 plus 250, right? Charged $150 per hour for 8 hours plus the initial $250, I wish it were $2.50, $250 initial meeting fee. So let's see what we come up with here. Could always rely on our handy dandy calculator if needed. We get 150 times 8 plus 250. We get $1,450. There you go. So that's how much the attorney will charge if she works for 8 hours. Next, this is probably a problem you're more used to seeing. If the total bill for the attorney's services was $2,200, how many hours did the attorney spend working? Well, this is now saying, instead of plugging in a value for x, saying this is how many hours, we're now plugging in a value for y, saying this is what I need the total cost to be. How many hours makes that happen? Okay, so we would say 2,200, our y, our output, should equal 150 times x plus 250. And now we can do a little bit of algebra to figure out, what x value makes that possible? How many hours does the attorney have to spend working? Let's figure it out. Let's start by subtracting 250 from both sides. That should give us 1,950 is equal to 150x. And we can use a handy dandy calculator, divide both sides by 150. And we get that x is 13. So divide both by 150. We get x is 13, meaning that it would take 13 hours, or rather, if the attorney worked for 13 hours, that's how long it would take to get the total bill of $2,200. So it would be 13 hours. All right. Hopefully that breakdown makes sense. Again, if you do have a question, please do not hesitate to reach out. All right. Next question. Let's move on. So this should be pretty familiar. Like I said, this should be something that you look at, we've done before, feels comfortable, makes sense as to how these components tie into the scenario. Here's something that also, again, is in the form of y equals mx plus b, but is a little less direct about the information that it gives. A little less direct about the information it gives. It states, the Cumberland Recreation Department charges a registration fee and a separate cost for each day spent at the town's summer camp. The total bill for a camper to attend for 12 days is $338, and the total bill for a camper to attend for 19 days is $506. Well, darn. If you notice right away, we're not given this rate. We're not saying, oh, the cost per day is this and the registration fee is this. That would make it really easy to figure out what my y equals mx plus b function should be. However, we are given enough information to find that. If you notice, we're given sort of two pairs of information. We're told that if I attend for 12 days, I'd have to pay $338. And we're told that if I attend for 19 days, I'd have to pay $506. What we can do with those pairs of information is exactly that. Pair them up and say, well, this is one pair of information and this is one pair of information. And given that we now have two pairs of information, two ordered pairs, we can find the slope of a line between two ordered pairs. We've done that a million times in the past with our good old slope formula, our rise over run, our change in y over change in x. We could say that the slope between these two lines is equal to the change in y sub 2 minus y sub 1, over the change in x sub 2 minus x sub 1. Here's our x sub 1, y sub 1. Here's our x sub 2, y sub 2. So let's see where this gets us. We would say here that the slope would be y sub 2 minus y sub 1, 506 minus 338, over y sub 1, x sub 2 minus x sub 1, 19 minus 12. And let's see what we get here. We're going to do 506 minus 338 gets us 168 in the numerator. In the denominator, 19 minus 12. Don't need a calculator for that one. That's 7. And then just do 168 divided by 7. We get that the slope here would be 24. Okay? Pretty steep line. But what that means is that the slope represents the daily fee, right? How much is charged per day? Well, think about our y equals mx plus b equation. Y equals mx plus b. Now I know that the slope is 24, so we'd have y equals 24 times x plus b. I still don't really know what b is yet, but we're going to figure that out in just a moment. But now we can kind of jump to say, well, just like how in this problem, first problem, this slope represented the hourly fee. Over here, this slope represents the daily fee because we're looking for a separate cost for each day as well as the one-time registration fee. So this 24 is the cost per each day, rather. So this is the cost per day. And now we can find the y-intercept. The way that we can find the y-intercept, the b value, is to actually just use one of our points here. I'm given a coordinate for x and y here. I'm given a coordinate for x and y here. It actually doesn't matter which one you pick, but I would probably gravitate towards the smaller one. We can substitute this value for x, substitute this value for y, because that's x and that's y, and figure out what b value would have to work in this function. If you remember, we kind of did that when we talked about parallel lines passing through a point, perpendicular lines passing through a point. It's the same sort of idea, right? We did actually problems like this where they were more straightforward. It said, write the equation of a line that passes through these 2 points. Well, we found the slope, and then we had to plug in x, plug in y to find that y-intercept. So that's exactly what we're going to do now. If I plug in some values here, we could say that 338, which is the y that I'll pick, is equal to 24 times 12 plus b. That would mean that 338 should equal 24 times 12. Let's see, 24 times 12 would be 288. I could probably done that in my head. 288 plus b. Subtracting 288 from both sides, I could do 338 minus 288. We get 50. Right? Is that correct? 50 is equal to b. And we're done. See that? Nothing else to do, right? And so now we could say that our formula in our y equals mx plus b form is 24x plus 50. That plus 50, just like it did over here for our first problem, now represents that initial registration fee, the one-time fee that's assessed. We'd be able to say that this is the registration fee. And again, that registration fee is $50. I should say that the cost per day is $24 per day. All right. And now that we have our equation in the form of y equals mx plus b, we could use that equation to figure out a question like this. How much would it cost to spend 30 days at summer camp? Well, I have my equation here. X represents the number of days, so let's just plug that in and say, well, y should equal $24 per day times 30 days that I'm spending at camp plus $50. Using a handy-dandy calculator here if you need it, I could say that 24 times 30, I think it's 720. It is. Okay, 720 plus 50. And so therefore, y would equal $770. So that's what it would cost to spend 30 days, just about a whole month, at summer camp. Alrighty. So with this problem, we had to go through a little bit of extra work in order to build my y equals mx plus b equation, but it's no different than the problems we had to do before, where it was, hey, can you write the equation of a line in y equals mx plus b form that passes through these 2 points? That's essentially what we're doing. We're doing the exact same thing. Passes through these 2 points. We find the slope using our slope formula. We start to build our equation, and then pick one of these values for x and y to plug in here and get my b value. All right. Let's take a look at 2 more examples now, one more of each that I'm going to go through with you. Feel free to try to do these on your own as I'm doing them here with you as well. All right, I think it's really good practice for you to try to do them on your own. So this first problem states, during a snowstorm, which is fitting because it's snowing outside right now, snow fell at a rate of ½ of an inch per hour for the entirety of the storm. Before the storm began, there were already 4 inches of snow on the ground. It wants us to make a equation of y equals mx plus b form. I think there was a sentence that probably said that here, and I think I left it out. So write an equation in slope-intercept form. What does the slope represent? What does the y-intercept represent? If the snowstorm lasted for 9 hours, how much snow was on the ground? So this is one where we're given the initial amount and we're given the rate directly, right? It's just like the first problem we saw with the attorney. So I'd say here that if I'm trying to build my equation in y equals mx plus b form, Before any snow started falling here, I know that there were already 4 inches of snow on the ground. That's a really bad situation. Already snow on the ground, and you know another storm's coming. It's just bad news all around. So, but we know that that's our initial amount. Before anything happens, we know there's 4 inches of snow on the ground. And that's exactly what the Y-intercept would represent, the initial snowfall. Now, snow is falling at a rate of half an inch per hour for the entirety of the snowstorm. So I could say that it's falling at a rate of 1/2 of an inch times the number of hours, 1/2 times x. Okay? So we'd now be able to say, well, this Y-intercept represents my initial snowfall, and this slope represents my rate per hour. Now, how many hours was it snowing for? This problem tells us, and it says here, if the snowstorm lasted for 9 hours, how much snow was on the ground? So we'd be able to say the total amount of snow, y equals 1/2 times 9 hours plus 4. Half of 9 is 4.5, so we'd be able to say it's 4.5 plus 4, or in other words, there would be 8.5 inches of snow on the ground. All right. Hopefully that makes sense as to how that was done. I know I kind of went through it a little quickly, but again, that should be a familiar word problem. We already took a look at one that was just like it, the attorney problem. Okay. Notice there could have been another type of question asked here. It could have said, instead of like how much snow was on the ground, it could have said, instead of if the snowstorm lasted for 9 hours, it could have said, if there were 8.5 inches of snow on the ground at the end of the storm, how many hours would it have snowed for? And we would have said, well, that means that 8.5 would have had to equal 1/2 times x plus 4, and kind of work backwards to say, oh, it must have snowed for 9 hours. So we could have worked backwards as well, depending on the given information. All right, last problem of the day. Here we go. This says, this will be just like the second one. A rental car company charges an initial fee plus a price per mile. One customer drove 250 miles and paid $56.50. Before I even go further, I'll say that's our first pair of information. I think my voice just cracked. That's our first pair of information. 250 miles, total cost of $56.50. Second pair of information coming up. Another customer drove 400 miles and paid $79. Drove 400 miles, paid $79. Write an equation in slope-intercept form that models the equation, and all the same thing up here. What does the slope represent? What does the y-intercept represent? And calculate the cost a customer should expect to pay if they drove 500 miles. So this is really a problem just like before. We're trying to find the equation of a line that passes through these 2 points. Well, we can figure that out by first finding the slope. We can say the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? The fact that we have a decimal here, 56.5, shouldn't make everybody nervous and panicky all of a sudden. It's done the same exact way. You have a calculator if you need it, so feel free to use it. I've been using it a lot today. So we can say here that our slope would be y sub 2 minus y sub 1. That's going to be, oh, I said x sub 1 here. My fault. This is y sub 2. My fault. Y sub 2. Okay, I would say y sub 2 is 79 minus y sub 1, 56.5, over x sub 2, 400, minus x sub 1, 250. Let's see what we get. 79 minus 56.5 gives us 22.5. Divided by 400 minus 250. I can do that in my head. That's 150. And let's see what we get. 22.5 divided by 150. We get 0.15, 0.15. And so we could say that that 0.15 is our slope. All right, doesn't necessarily have to be a fraction. You could do 15 over 100 if you want, which would reduce to, oh boy, 3 over 20. You could do that if you certainly wanted to, but you could just leave it as decimal as well. And you could say that your equation so far is y equals your slope point, 0.15 times x plus your y-intercept, the initial fee, which we don't know. But we can figure out what that initial fee is by plugging in either of these pairs for x and y. Personally, I'd probably choose the second one. Even though the numbers are a little bigger, it avoids fractions and decimals, so let's try it. I'd say here, to figure out my y-intercept, that 79 equals 0.15 times 400 plus b. Kind of went off the page there. Plus b. Let's see what we get. That means 79 should equal 0.15 times 400. I hope that works out nicely. Times 400. Look at that. It does. We get 60 plus b. And then just subtracting 60 from both sides. 79 minus 60 should be 19. So that means that the initial fee of renting the car is $19. Meaning we could take that b value, put it right back up here, and say my function is y equals 0.15 times x plus 19. Again, remember this 0.15 represents the price per mile. It's 15 cents a mile. And over here, this 19 represents your y-intercept. So that's how we can build the function. All right. Again, this should be very familiar in the sense that we've done problems like this before, not necessarily tied to applications, but just if you have 2 points, can you find the equation of a line? You find the slope first, put that in there, and then plug in one of the points for x and y to find the b, the y-intercept. Now it's just taking it one step further, tying it to an application. And we can say here, calculate the cost the customer should expect to pay if they drove 500 miles, meaning we're going to plug in 500 for x, and answer this by saying the total cost should equal 0.15 times our 500 miles plus 19. Let's see what we get here. 0.15 times 500 is 75. So we get y equals 75 plus 19. And so that means that y should equal 94. Meaning that we should expect to pay $94. And that kind of makes sense too. Another important point to make right at the end here is to kind of think about that and think about it in the context of the problem and see, does that make sense? If this customer is driving for 400 miles and paying $79, well then, if I drive for 500 miles, I should certainly get an answer greater than that. But not like monumentally greater, right? You notice that going up from $250 to $400 is an increase of like about $23, $22.50. So going up from 400 to 500, kind of a similar increase, should be somewhat of a similar increase in price. It shouldn't immediately jump up to like hundreds and hundreds of dollars. Likewise, it also shouldn't be below $79. That wouldn't make any sense. If you drive longer, now all of a sudden it's cheaper. That doesn't make sense. So it's always worthwhile too to just take like 5 extra seconds at the end of your problem and say, does that answer kind of make sense? Is that what I'm expecting to get? In this case, 94, not only is it the correct answer, but it's definitely a reasonable answer given the information I have in this problem. All right. Hopefully that made sense, and we were able to explore some more applications of linear functions. We will have more time to practice this later this week and into next week. So, do your very best. If you have any questions, reach out and let me know. But thank you so much for your attention and focus, and I'll see you around. Bye, everyone.